Welcome to the Explainer. Today we're diving into something in Java that seems super simple on the surface, but is secretly the source of some of the most frustrating and costly bugs out there. The difference between primitives and their object wrappers.
I mean, it's a fair question, right? Why have both int and integer? Well, the answer gets to the very heart of Java's design. And trust me, getting this wrong isn't just about writing confusing code. It can and will crash your entire application.
All right, so to really get this, you have to picture Java as having these two parallel worlds living side by side. On the outside, they look almost the same, but underneath, they play by a completely different set of rules.
So in one world, you have your primitives. Think of these as just the raw, simple data. An int, a double, they're nothing fancy, just a value. And because they're so simple, they are lightning fast. Then, in the other world, you have objects. These are the wrappers, like integer. They're more like sophisticated containers that hold those raw values, but they also come with extra powers, like methods you can call on them.
Okay, so if primitives are so fast, why don't we just use them for everything? Why do we even need these fancier, more complex wrapper objects in the first place?
Well, it really comes down to this. Huge, powerful parts of the Java world, especially things like collections, your lists and maps, they were built to work only with objects. They just don't speak the language of primitives. So wrappers are the essential bridge that lets our simple values cross over and work with these more advanced tools. And wrappers introduce a superpower that primitives just don't have, the ability to be null, to represent the absence of a value. And that little detail, keep that in the back of your mind, because it's going to come back in a big way.
Now, to make crossing this bridge between the two worlds feel seamless, Java's creators added a little bit of compiler magic. It makes your life easier, but as you're about to see, this magic has a bit of a dark side. This magic has a name. It's called autoboxing and unboxing. Autoboxing is when the compiler sees you have a primitive int and just automatically wraps it up in an integer object for you. And unboxing? You guessed it. It's the exact opposite. It takes that integer object and automatically pulls the primitive int value back out. And when you look at it in the code, it's so clean you might not even notice it's happening. You can just assign a primitive to an object variable, and vice versa. The compiler handles all the messy details. But that convenience, that's where the danger is hiding. So, this brings us to the most important part of this whole thing, the three critical traps where this compiler magic completely breaks down. Let's walk through them, so you can learn to spot them and avoid them for good. The first one, this one is by far the most common. I like to call it the silent killer, because it waits for the absolute worst time to blow up your application. And it all goes back to that special null value we talked about.
All right, have a look at this. We create an integer object and we set it to null. Totally fine, an object can be null. But then we try to assign that null object to a primitive int variable. And remember, a primitive int cannot be null. So, what happens when the compiler tries to unbox something that isn't actually there?
Boom! Your program dies. Instantly. You get the dreaded null pointer exception. And it's because that magic unboxing is really just the compiler trying to call a method on your object to get the value. But you can't call a method on null. It's a fatal error.
Okay, trap number 2 is way more subtle, and it causes the kind of bugs that will have you pulling your hair out for hours. It all comes down to a simple question. How do you compare two wrapper objects? Okay, check this out, because this is where it gets weird. If you compare two integer objects with the value 127 using double equals, you get true. But do the exact same thing with the number 128, and you get false. What is going on? Well, for performance, Java keeps a special cache of integer objects for small numbers, usually from -128 to 127. In that range, it just reuses the same object. Outside that range, it creates a brand new object every single time, and that makes the equals operator completely unreliable. And this leads us to the absolute golden rule. It all boils down to this. The double equals operator asks, are these the exact same object in memory? The dot equals method asks, do these two objects hold the same underlying value inside? And with wrappers, it's the value you almost always care about. So please always use dot equals. And finally, trap number 3, performance. All of this automatic wrapping and unwrapping, this magic, it isn't free. Think about it. In a tight loop that runs millions of times, or when you're processing a huge list of numbers with a stream, you're potentially creating millions of tiny, temporary objects that the garbage collector then has to clean up. All of that extra work can seriously drag your application's performance down.
All right, so now that we've seen all the scary stuff, how do we actually deal with it? How do we use these tools like a pro? Let's get into the playbook. A few simple best practices for writing code that's both safe and efficient.
First, the do's. When you need to create a wrapper, use integer.valueOf. It's just smarter because it takes advantage of that cache we talked about. Next, when you compare them, always use .equals. And third, when you're doing heavy-duty number crunching, use primitive streams like inStream to completely avoid the boxing overhead in the first place.
And just as important are the avoids. On the flip side, never just assume that double equals is going to work for wrapper values. Always, and I mean always, check for null before you let an integer get unboxed to an int. And finally, just be mindful of those tight loops where you might be accidentally creating thousands of objects without realizing it. So there you have it. That bridge between primitives and objects is absolutely essential in Java, but it is loaded with these hidden traps. By understanding where that magic of autoboxing can go wrong, with nulls, with comparisons, and with performance, you can start writing much safer, much more efficient code. So my question to you is, now that you know the rules, what's one hidden trap in your own code that you can go and fix right now?